It's time for Myth of the Week.
All right, thanks so much for the participation this week. Had a lot of people jump in on the Nat King Code page, and it just means a lot. You know, this is one of those installations. If anybody remembers, this goes back. I've used a lot of my illustrations for different things. Not illustrations, but my pictures. This was something where I was doing a plant, and I was actually adding another one of these pieces of equipment. This was a heating furnace, and you could tell that they have the phases reversed to have correct rotation. I want to say it was a clockwise rotation service, and this machine ran counterclockwise, so they had to switch the phases around to get it to spin correctly. And I think it was just the induction motor for this. It was like a furnace, like a blast furnace. So what ended up happening was they had inductive heating on this. So the plant electrician, he wasn't really an electrician, but he was the plant guy who installed it. And he put all the browns in one pipe, all the yellows in one pipe, and all the oranges in one pipe.
Wrong.
And he basically created a gigantic heater. And so it was pretty crazy, and we ended up having to fix this. So this is like after we shut it down, like what we ended up doing was I believe those were 250 aluminum, and we went and took the 250s out and pulled in 500s, because obviously you can't just take four 250s and four 250s to get 1,000 when you could just do that same thing. I think we ended up knocking the fuse down and going with like 900, I think, or 1,000 with parallel 500s, because that's the only pipe we had. But it was funny because, and this was real interesting because I used this with, we had Crystal Hunter on, and we talked about it because it looked like they used Deox on this. I think when we were doing the close-up on the show, you could see it looks like they did actually use it. But the interesting thing was this plant electrician or maintenance tech, he said, oh yeah, I have a torque program, and I go through and I torque these lugs every so often, And so, of course, the curiosity of me is like, I want to see how tight they are. And I just walked over, grabbed that yellow, just ripped it right out of the lug. So I just kind of wanted to show that, it was, something else, but it was kind of funny because one of the other code instructors out there was saying that had to be identified all the way up to the terminal, and that's wrong. And when you actually look at it, it really only says that you only have to encircle the conductor one wrap. So that's pretty interesting too, running into that. But, the big thing that really always cracks me up about this is you'll always hear these guys say it must be at least 6 inches of identification, and you'll never find that anywhere in the code. And David makes the comment that, there's no length specified, And there's actually other areas of the code too, David. I believe 200.6 actually mentions that you must encircle the conductor with one, at least encircle the conductor. So that's pretty interesting to look at. And a lot of times what we do out in gas and oil is we do like a tiger stripe, and I think it looks a lot neater. And I'll tell you too, James, the thing that was funny about this is kind of where I knew there was a problem. So if you go and look at the breaker, you can see it's like brown, yellow, orange, and it's like labeled, as to what the phases are. Well, then I went and I saw the conduits, and he had the conduits labeled, And that's where I knew there was a problem. I was like, wait a minute. I was like, why does this conduit have a brown tape wrapped around it, and this conduit have a yellow tape wrapped around it, this conduit have an orange tape wrapped around it? And I had noticed that the conduits were a little warm, And so I told the head maintenance guy at the plant, I was like, dude, I was like, you guys got conduits that are getting warm, dude. Something you ain't got something right, you know. And so he's like, oh well, you know, he goes, that furnace is drawing like 800 and some amps when it's heating, you know. So he's like, next time that thing's in a heating cycle, he's like, come get me, we'll put a temp gun on it. I'm like, all right. So I take the cover off, and it's just basically an empty section that's above the gear, just to start kind of trying to figure out my parallels, punch it out and stuff. And I noticed it was like a little bit more warm than the last time I saw it, you know. And all of a sudden, I noticed that he only pulled one ground wire, and the ground wire was smoking. And so I went and I grabbed him. I'm like, get your temp gun, you know. I was like, something's up, you know. So he goes and grabs his temp gun. The equipment grounding conductor was like 187 degrees or something like that. It was crazy. Damn. And then he shot one of the couplings and it was almost 300. And so David's saying that 310.6 identifies, oh, okay, so it ties in the grounding conductor and the equipment grounding conductor. Gotcha. Okay. That's good to know, and that's why you have to look at the code as a whole. You can't just look at one section and say that's the be-all, end-all. So anyway, we went and we took a look at it, and the furnace wasn't heating at that time, and so we're like, shut it down. They were actually finishing their one batch, and like I think they only had like 3 minutes left on it. So we're like, let's go ahead and finish this batch after 3 minutes. Let's shut this thing down and let's figure out how to get it fixed, you know. But come to find out, the reason that ground was smoking like that is because it was trying to balance the current. It was trying to act as a neutral.
Mm-hmm.
And so it was trying to take that unbalanced load of all those, that inductive heating, you know. And it was doing a decent job, you know. I think it was like a 3-aught or something like that. It was like a 3-aught copper or maybe a 2-aught copper, but it was doing a decent job for what size it was. Maybe it was even smaller than that, but I remember I went and looked up the ampacity of it, and it was far beyond the ampacity for that conductor. So it was pretty crazy, but, you know, like I say, to me, this is more or less just a trade kind of thing. Like we don't need the NEC to sit there and tell us every little thing that we need to do. You know, like, I just don't understand how these people are like, code doesn't say that. Well, maybe you should be a craftsman and just do it right, you know? So,
well,
to me personally, I would like to have at least a decent amount of 4 to 6 inches to make sure there's no confusion and identification. You can obviously look that he didn't do a very good job on that orange. Like, he marked that orange, like, further down the conductor, you know. So at least make them similar. Excuse me.
Yeah. Well, when I looked at this, I gave it a few thoughts, but one of the main things I wanted to point out, this was something, being instructor for NFPA, we actually went over this, and we actually used a PowerPoint too. And the thing that was interesting, that they set it up in such a manner, and I agreed 100% because we actually had it in our publications this way, but we talked about reserve colors. And when you look at NFPA, they reserve certain colors. So if you're looking at equipment grounding, you got green with one or more yellow stripes, or bare. Okay, that's right. One of their reserve colors. The other reserve color is when you go look at 200.6 A and B is for the neutral, and you got white or gray, or you have white or gray with a stripe other than green. Then there's right. Other certain things that are in the code. You could go over and look at an intrinsically safe circuit, it's light blue. If I'm looking at other conductors like high legs and things like that, you got reserve colors that they want you to use. So when I was going through the apprenticeship, we used to always be taught this. If we had a 120, 208, 120, 240 volt system, well, we were taught black, red, and blue, and white for the neutral. If it was a
Yeah,
two,
and that would kind of align with what David's saying here with 210.5, and you have that up on your slide right now. But that's the whole thing that's kind of controversial about that is if you have the different voltages in that building. So
well, and
I've
I'll
seen a
go over
lot of
that.
guys. I've seen a lot of guys that are like, no, you have to have red MC cable and you have to have blue MC cable and it's only 120 208 in the building. So it's like, why do you need to, worry about all that? Oh yeah, there's a new code. You can't do that anymore. And then Daniel's seen it firsthand. I've had Daniel like rolling laughing on some of these posts that I posted up there where I'm like, hey, can I do this? And they're like, no, you can't do that, And it's like, dude, I literally posted a picture of me doing it, and you're saying I can't. It's
Well,
ridiculous. So
and
that kind of goes in with the meme too.
yeah, well, what you get into is, let's say that I come in and there's at my panel board, I'm 277, 480. And I come out of that panel board with a branch circuit and I hit a junction box there and I'm going feeding different things. And then I come out of that same panel and I go over and hit a step down transformer and establish another panel board with a 120 208 volt. And then I come out of there with a branch circuit and I enter into that same junction box. Now what happens is you got two different system voltages. And
Right.
when you're looking at the neutral, you want to go look at 200.6D. And when you look at, now this was interesting because there was a point where my coach was actually teaching this. He said, if you have a white, then the other one you have to put in would have to be a gray with a colored stripe other than green. And I remember where I was in Dayton, Ohio doing a code change course. And a bunch of students were asking me, and I said, no, that isn't true. I said, who was the instructor? That's how come I know who it was. And I said, what was his reason? And he said, well, he said over time you couldn't tell the difference between the two different conductors. I said, well, that's not true. And so you can go look at this. If I'm not mistaken, I think Mike had made a proposal to put that in there like that, and the code making panel rejected it. And what they ended up doing, they put a list system in. And if you go over and look at 200.6D, I think it states, I think the heading says grounded conductors, a different nominal voltage systems or voltage systems, something like that. But when you go over and look at it, they tell you that you got that grounded conductor has to conform with 200.6 AB, 6A or B.
Yeah.
And then,
And David makes a good point that you have to post those different voltage, like signage.
you
And
do.
I can't remember exactly when. It was a few cycles ago. They actually added that neutral had to be posted with it because they never had that before. So They actually had it to where all you had to post was your ungrounded colors. And then they added that neutral. I want to say it was in 2017, possibly 2014, because I remember going through a bunch of buildings and changing it.
Yeah, and matter of fact, if I'm not mistaken, they give you the three options that you go down and follow. And then if I'm not mistaken, it got added in there about the means for identification. And they tell you that it has to be readily available or it has to be permanently posted where you have the different systems originate. So
Right.
I think it's the last sentence that's in 200.6D. And when you go look at that and everything, that's why I'm trying to bring this up, is basically you can take your identifications for your branch circuits, and then you come here and you look at your identification of your ungrounded conductors here. It tells you about the means of identification. There's nothing talking about the 6 inches or anything like that. Then you go to 215.12, you get the same thing. Okay, for the
Right.
equipment grounds and the grounded conductor. So it takes you
Yeah.
back to exactly where I was
D-
talking about. You pick this
David's following
information
you,
up.
brother. He's
Oh
right
yeah.
on it.
hmm And that's why I say you go and you look at this stuff and you start putting it together. Basically, your system voltages that are coming in, you can use any colors you want to use to identify it, but you got to post there and tell what that identification is. However, if I'm using a neutral and equipment ground, you have to follow because those are reserved colors that are used to specify those type of conductors. Okay,
Right.
so that's why I wanted to point it out. And then where you got the service conductor with higher voltage to ground, here's a good example. And we tell you that you permanently have to identify that outer finish. That is what color? Orange. Okay,
Yeah.
so I just given a few little examples there. I wanted to sort of take that. It's one thing about the identification of the conductors, but and how many wraps or whatever that's not there. You got to identify that conductor. The means that you do it. Hell, you could put a tag on it. I mean,
Yeah.
there's ways that you can do that, and
We've
that's
we've
why.
had times we've had times before out gas and oil where we've had to do it like A1, A2, A3,
Oh yeah, I've seen that
or
too.
whatever, because we didn't have any choice. We didn't have a way to get colored tags on them.
hmm
And then what we've done is we've used like a white heat shrink, and then
hmm
all we do is we print out A1, A2, A3, and then you can change those if you need to based on motor rotation.
Sure,
You might have to have A2, A1, A3 at the motor.
that's right.
Or now I was talking to one of the guys in the comments, because he's like, oh yeah, you gotta, it's easier to change it at the motor controller, which he's right. But a lot of these freak drives that I've seen coming out now, you can just reverse the rotation right at the freak drive now. You can just
hmm
go in there and just change it. You don't have to even swap any wiring.
Sure,
So
and I think this is a good myth, and I think adding to it a little bit so people understand about reserve colors and that of the National Electrical Code. I gave some good examples there, and hopefully that clarifies that and everybody knowing that you don't need 6 inches.